Okay, so in this problem we have a Ferris wheel. The Ferris wheel is rotating with a constant velocity, okay? We have a child of mass m, and we're looking at basically, so he moves in a vertical circle with a radius of 10 meters and a constant speed of 3 meters per second. So constant speed, constant speed. We want to determine the force exerted by the seat on the child, so the normal force, at the bottom of the ride. And then we want to determine the force exerted by the seat on the child at the top of the ride. So we're trying to figure out his normal force at the top and at the bottom. Okay, so that's the force from the seat. So how much does he weigh on the, like how much does it feel like he weighs on the top and on the bottom? How much is the seat pressing up against him? Okay, so let's address one thing first. When we have something rotating in a circle, remember that at all points, so all of these objects are experiencing this centripetal acceleration, right, pointing towards the center of the circle. I'm also going to choose my coordinate system to be this before I start. So I'm going to choose this to be positive y, and I'm going to choose this to be positive x. Okay, so positive, right, and positive, just by choice. Okay, so let's start with some fy, and I'm going to look at the bottom. Okay, so what's going on for our bottom person here? So we're going to start just by looking at him. Okay, so at the bottom, for our sum of forces in the y, we have n bot, it's positive because it's pointing up, minus mg because it's pointing down, and we're going to have that equal to a positive mac, okay, which is going to be equal to mv squared over r, okay? So, because our centripetal acceleration equation, just standard here, is v squared over r, and notice that that v is actually that tangent velocity. So this v here is that 3 meters per second that we were given, the constant speed that it's rotating with linearly. So this is linear speed. Okay. All right. Now sum of forces for the top. Okay, so we have n top is equal, n top minus mg, same thing. But notice that in this case we have our centripetal acceleration is pointing down. We chose this to be positive y, so this is actually going to be negative. So it's going to be negative mac. Okay, so we always set f equals ma, right? So always force is equal to mass times acceleration, and direction is important. Okay, so that's going to be equal to negative mv squared over r. Cool. Okay, so we're trying to solve for the normal force. So for the bottom, n bottom is going to be equal to mv squared over r plus mg, and top is going to be equal to negative mv squared over r plus mg. Okay, so notice that at the top, just by first glance, right, at the top, that value is going to be higher, right? That's going to be more than this because at the top we have the weight, right, minus the centripetal acceleration, and then at the bottom we have the weight plus the centripetal acceleration. Okay, so if we simplified these a little bit more, basically by plugging in our numbers here, what we would get, if we kind of rearrange things a little bit, I'll leave you to the solution guide to do that part. I just want to kind of conceptually touch on things here and not make these too long. So I would end up 1.09 mg, just plugging in the numbers that I have. And then for this one, I would end up with 0.908 mg, because I ask you to solve for it in terms of like multiply by mass times gravity. So the units for this is actually newtons, because this is a force. The normal force is a force. But they wanted to basically have you set it up this way so you could look at the ratio of the weights. So at the bottom, note that he's going to feel like he weighs more here, versus at the top, he's going to feel like he weighs less here, right? Because the centripetal acceleration is detracting from the weight. Let me just make sure I got that right here. So top, 0.908, feel like you weigh less. Bottom, feel like you weigh more, because you're basically spinning towards the bottom. Okay, so that is this problem. If you have any questions, please feel free to post them in the chat, and I will try to get to them as well.